So this is going to be a video on kind of the homework review. So we're just going to take a few problems from the homework that was assigned through Alex, or at least problems of similar types, and just kind of work through them. So these might not be the exact same problems you have done, but they should be of similar types. Excuse me. So let's look at this first one here. A company has 12 salespeople. The board asks for a list of the top 4 salespeople in order of rank, so in order of effectiveness. So how many lists are possible, assuming that the order of salespeople on the list is relevant. So again, relevant meaning that the order does matter, because obviously the first person listed would be the person that's most effective, because it says ranked in order of effectiveness. So again, we can think about this as permutations and combinations, which it is. It's a permutation because the order matters. So we could do 12 pick 4. So 12 pick 4. And that would give us, if we erase this here, 12, whoops, where'd it go? There it goes. 12 pick 4, and we get 1180. So 11, not 80, what am I talking about? 1180. And then that would be how many lists are possible, because again, the order is relevant. So when you switch the order, that means there's obviously somebody else is ranked first. So if Billy was first on the list, and then if we put him second, that means something different. That means he's second most effective rather than first most. Or you can think about this in terms of a list as well. So think about it as you have 4 spots. Now, technically speaking, any one of the 12 could be the best, right? Any one of the 12 could be the most effective. So you have 12 possible people for the first spot. Then you have 11 possible people for the next spot, right? Because this person can't obviously be first and second. If Bill was picked first, he can't also be second. So there's only 11 people that can fill this spot. And then 10 only for this spot, and then 9 only for this spot. And so if we multiply this down, we should, if all goes correctly, get the same answers. Let's see if Mr. Paulus is doing his stuff correctly here. Times 10 times 9. And yes, we get 1188.0. So I don't have to remake this video, hopefully. So 1188.0. Now, to roll the dice even further, you could think about this one more way, and that's using the formula. So remember, the NPR formula by hand is actually this: n factorial over n minus r factorial. So where n is the total number of things you have, and r is the number that you're picking from. So I have 12 total people that I'm picking, or that I have, and I'm picking 4 from those. So 12 minus 4 factorial, which is 12 factorial over, that'd be 8 factorial. And so if we do some arithmetic here, make sure I put these in parentheses because I'm paranoid about parentheses. So if we do 12 factorial over 8 factorial, we should end up getting the exact same answer, 1188.0. I'm on a roll. 1188.0. So no matter how you think about this, you always get the same answer. So you have basically 3 options of doing it. You have the formula that the calculator has built in. You have kind of a thinking about it in terms of a list procedure, so you can kind of figure out what the numbers would be yourself, or you can just remember the formula anyway and just use that. So, excuse me, 3 options, whichever one you want to do, take your pick. What about this one here? So we have 17 customers. 5 are to be chosen to receive a special gift. Assume that the order in which the customers are chosen are irrelevant. How many groups of 5 customers can be chosen? So obviously this was done in a point in time where stores had customers, right? Anyway, so we have 17 customers. It says the order chosen is irrelevant. So it's a combinations question, because if the order does not matter, that means it's a combinations. So if I pick Andy, Billy, Charles, Doug, and Eric, if I pick them to receive the gift, that's no different than if I switch these around. If I picked Becky first and then, Bill first and then Andy. I forgot the names I made here. But if I pick B first before A, they still all get the same prize. So the order here doesn't matter. So it's a combinations questions. So once again, we have kind of that same formula. We have 17, choose 5, which is also, once again, in the calculator. 17, choose 5, which is 6188. So there's 6,188 ways that you could pick the winners from this group of 17 customers. And again, if you want the formula is pretty much the same thing as the other one, n factorial over n minus r factorial times r factorial. So n here would be 17, r would be 5. You plug those numbers in and you get the same answer as well. So whichever way you want to think about it, you can go that way. This really doesn't do well in terms of a list format because of the fact that the order is irrelevant. So it's a little bit harder to do that in terms of a list. So usually we stick to either using 17C5 or using the factorial formula. All right, so this next one here, we have serial numbers for a product are made by using 2 letters and followed by 3 digits. And the letters are taken from the first 8 letters of the alphabet with no repeats, and the digits are taken from the first 10 digits with no repeats. How many serial numbers can be generated? All right, so you can do this again one of two ways. You can think about it in terms of a list, which is what I would do because that's how I usually grew up looking at these problems here. So 2 letters followed by 3 digits. Now this is what makes it so that you can actually do it as a list. It gives you the order. 2 letters first, followed by 3 digits second. If they didn't say this, if they said the letters and the digits can be in any order we want, that'd be something else we'd have to tackle there, which we're actually going to do in the next problem, believe it or not. But if it says that it can be 2 letters followed by 3 digits, and that's the order that it has to go in, we can think about that again in terms of a list. 2 letters, and then 1, 2, 3 digits. So these will be my letters, and these will be my digits. And it says the letters are to be taken from the first 8 letters. So we have 8 letters to deal with here. So any of those 8 letters can be my first letter. And it says no repeats. So that means I only have 7 letters that can be my second. So 8 letters for my first possible pick, 7 letters for my second possible pick. Because again, they can't use the same letter twice. And it says the digits, which are these, are to be taken from the 10 digits with no repeats. So 0 through 9, those are the digits, and you can't pick the same number twice because there's no repeats. So once again, I have 10 possible digits I can put in this one. I have 9 possible I can put in here because it's 1 less. And then I have 8 possible I can put in here because, again, I can't use either of these two numbers when I choose them. So I can just kind of multiply this all the way through now. Multiply my possible letter combination, multiply my possible digit combination, multiply them together. So 8 times 7 times 10 times, I should put 9 first, although it really doesn't matter, 9 times 8, and we get 4032.0. So that's one way of doing this. Again, think about this in terms of a list, because it is kind of a permutations, and permutations do have that option for them in most cases. However, you could also think about this as I just said, 2 permutations. Think about this as its own NPR, and think about this as its own NPR. So 2 letters out of the first 8. So out of the 8 letters, I'm going to pick 2 of them times. And then for the digits, it's out of the 10 digits, I'm going to pick 3 of them. So 10 digits, pick 3. Let me make that 3 better. I tried to save it, but I just couldn't. So 10 digits, pick 3. 8 letters, pick 2. And so if you do this, you get pretty much the same thing we did. So 8, pick 2, we get 56 times 10, pick 3, we get 720. And again, notice I'm doing permutations because the order does matter. If we're making a serial number of AB is going to be different than a serial number of BA. So make sure that we're doing a permutation thing here because it is not a combination because the order does matter. So 720, 720 times 56 gives us, again, the same answer, 4032.0. 40,320. I do know how to say the numbers, by the way. I just say that so I remember how to write it down. So 40,320 different ways that we can make these serial numbers using these restrictions here. So if you have 40,321 products, you're going to need a new style of serial numbers, evidently, or at least the ability to reuse old ones that are no longer in use. So again, this is a permutations questions because the order does matter. So if you did this with C's, you would get a different answer than the target one, which again is why I usually like to think about these problems in terms of a list, because then I don't have to worry about whether it's the order or whether it's not. All I need to make sure about is that it has a set arrangement for how it wants the categories. So letters first, followed by 3 digits in that order. And then it gives me the amount of items for each category, 8 letters to pick from. You're going to choose 2 of them. 10 digits to pick from, you're going to do 3 of them. As long as I have that information, I can do it in terms of this like little list format thing. And this one here, it says a history class is comprised of 10 female and 9 male students. If the instructor chooses randomly from 9 students, what is the probability that 6 female and 3 male will be selected? So notice how there's a subtle difference between this problem and the last one. It still has 2 categories, male and female, but it didn't say what order that they're going to pick in. It didn't say that I want 6 of the first ones to be female and then the last 3 to be male, or vice versa. It just said, out of the total, I want 6 female and 3 male, and it says round your answer to 3 decimal places. So in order to solve this one, I can't use permutation. I can't use the trick I did last time because I don't have a set order. I could get these female and male students in any way I want. I can do all 6 female and 3 male. Or I can do all 3 male and then 6 female. I can split them up and do kind of half and half. So it's because I don't know the order in which I'm going to pick them, I have to use a combination style of questions here. And it also asks for the probability. So it wants a fraction or a probability answer, not just a number of ways. So we break this usually into 3 parts. The first part is what we'll call total combinations. Total ways that these things can be arranged. Now again, this is a combinations kind of question because if you're picked for the exam, it doesn't matter whether you're picked first or last, you're still going to be taking the exam, right? So this is a combinations because the order does not matter in this case. So we have a total of 19 people, right? 10 female, 9 male is 19 people total. So we have 19, and we're going to choose 9 of them. So 19 choose 9. So how many ways can we pick 9 students from 19? How many different ways can that happen? Well, there's 92,378 ways. 92,378 ways. That's the total number of ways I can do this. That's going to be my bottom number in my probability fraction. That's my total number of outcomes. 92,378 ways. My second step is to figure out the combinations for my first category. So we'll do the combinations for female. So I have 10 female students, and I want to choose 6 of them. So 10 female, choose 6. Not pick, so it's not a permutation, again, because I don't care what the order I pick them in. I just want 10C6. Again, combinations is very important here. So 10, nope, not alpha. 10, choose 6. We get 210. And then that's that. So that's how many ways I can pick 6 females from 10 females total. And then I'm going to do my male combination. So I have 9 male students, so 9, choose 3. So 9, choose 3. We get 84. And then we're going to multiply these together. And we're going to do 210 times 84. And we get 17,640. So 17,640. And so 17,640. And then we're going to divide these out, and that will give me my probability. So that divided by 92,378. And we get about 19%. So it says round to 3 decimal spots. Now, this is kind of tricky because we are using a computer system for our answers, so it can be kind of stingy. So you might want to make sure that if you get this wrong and you know it's just a rounding error, make sure you look at how they rounded their answer, because this could mean one of 2 things when it says round to 3 decimal spots. It could mean take this, round to 3 decimal spots, and then make it into a percent. So if I just take this and round to 3 decimal spots first, that 9 would bump the 0 up to a 1. So it'd be 0.191, which would make it 19.1%. Or it could be make this into a percent first and then round, which in this case would be roughly the same. So it'd be that would be 19.095. So 19.095, because that's 3 decimal spots out, right? So if I dump this decimal back twice, I get 19.095, and that 5 would round the 9 up to a 10, and that 10 would round that 0 up to a 1. So this would end up being 19.1 as well. But if that was like a 4 there, then technically my answer would be 19.094 or something like that. Because actually I think after the 5 is also a 4. So actually this could technically also be considered a final answer too, because this is the percent rounded to 3 decimal spots. So again, when they ask you to round, it's always kind of a issue until you've done it once. But the way I would suggest you do it to avoid that, get that 19 better here. The way I would suggest you do it is leave your answer like this. This is typically how they want it when they say round up 3 decimal spots. They usually don't want you to make it into a percent, like this or this, because that's inherently just kind of weird when they ask you to round to decimal places. So leave your answer kind of like this, a decimal rounded 3 decimal spots, and then if you get it wrong and you know it's a rounding issue, look at how they made their answer, look at what they did via rounding, and then make sure you do that from then on. Again, this is also why you want to upload your handwritten work to Google Classroom. That way, if it does count you wrong, I can go to your work, see that you did it right, you just rounded differently, or maybe there's a slight rounding error, but then I can give you the partial credit or the full credit if it's a really minor issue. So again, please always upload your handwritten work for your highest scoring RPS or quiz to Google Classroom so I can give you that partial credit that you earned. And then last one here. An urn contains 7 green and 6 black balls. 6 balls are randomly drawn from the urn in succession with replacement. So that means that after we draw a ball, we put it back in. What's the chance that we draw 6 green balls? So in this case, it kind of is telling me the order because it says it wants all the balls to be green. And again, we want to put each ball back after each draw. Well, we just have to kind of think here, okay, how many total balls are there? So this urn has a total of 7 plus 6, which is going to be 13 balls. So if I want to draw a green ball on my first pick, and there are 7 green balls to choose from, that means it's 7 out of 13 chance for my first pick. Now if I draw that green ball and keep it, that means there's a 6 out of 12 chance for my second pick. Why? Well, because there's one less green ball, because I drew it my first draw, and there's one less ball total because, again, I took that green ball out and I kept it. And then for the third pick, it's going to be the same thing. There's one less green ball, so it's going to be 5. And then out of 11. And then 4 out of 10. You can kind of see where this is going now. And then 1, 2, 3, 4. So that'd be 3 out of 9. And then finally 2 out of 8. So 1, 2, 3, 4, 5, 6 picks. All are green. So if we multiply this all together here, we'd have 7. Let me just do this in one go here. 7 times 6 times 5 times 4 times 3 times 2 divided by 13 times 12 times 11 times 10 times 9 times 8. Whoops, times 9 times 8. And we get 0.004. It says rounded 3 decimal places, so we're just going to write it as, let's see, after the 4 is a 0, so yeah. So 0.004, which is less than 1%. It's about almost 0.5%, actually, a little bit less than 0.5%. So that will be how you'd solve these problems here, is again, you kind of just deal with it by making a list and figuring out, okay, probability of the first times probability of the second times the probability of the third, and so on and so forth. If they said, I want 5 green balls and then 1 black ball at the end, so they said, I want you to draw 5 green balls in a row first, and the last ball I want you to draw will be black, then it would be roughly the same thing. It'd still be 7 out of 13 times 6 out of 12 times 5 out of 11 times 4 out of 10 times 3 out of 9. But then the last draw, if I want it to be black, would be 6 black balls out of 8. And that would be my last fraction there, because these would all be green, 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 and this one is the one I want to be black. So again, in order to do these problems this way, they'd have to give you an order, like 3 green and then 3 black, or 2 green, 1 black, 2 green, 1 black, or all green and then the last one black. So as long as they give it to you as an order, you can always think about it in terms of sort of a list here, which they didn't explicitly do here, but they kind of did because they say all 6 are green. So that's the order, 6 in a row. But they have to give you that. Otherwise, you can't do it like that. You're going to be going to a problem that's more like this, where they didn't give you an order of how they want you to pick the classes or how they want you to pick the students. They just gave you what they wanted in the end. So again, combination style of question because the order didn't matter. Permutation style question with probability because the order did matter. I want all 6 to be green, which is, again, the only order I'm caring about. So again, those are the most common questions that I figured people would struggle with. Again, if you have another question that I didn't get to or that I didn't pick, please let me know and I can help you work that out. Alex does a good job of doing some explanations on their own too, but I figured I'd make this for those of you that are more used to how I talk about things and how I instruct things rather than the way Alex does it. So again, if you have any questions, let me know. Please make sure you get your homework and RPS done before the end of the week, and Hope you enjoy the video and have a good day. Nope, not that one.